you're certainly 50% faster, and in some instances up to 70% faster. So yes, I could replace 2 or 3 competitive, slower, let's say, 40 taper type machines.
Peter, here at Whitehouse Machine Tools, the SPEEDIO F600X1 from Brother. What's changed? What's new about this machine?
So from a development point of view, Brother are well known for their 30 taper technology. Originally starting off with drill tap machines, and that's then progressed with different designs and technologies into more capable materials. The F600 is a specific machine aimed at purely tough materials. It'll handle softer materials very, very easily, but it's specifically aimed at tough materials with its design. So there's a few key features in there about it's got a bigger spindle, bearing diameter. It's got as much power and as much torque as a 40 taper spindle. We've got more servo axis thrust from a cutting point of view. It's got bigger ball screws. And from a design point of view, there's a slightly different design in that now we've got purely a moving Y-axis, where the travelling column element is X and Z. And the whole idea of that is to keep the spindle centre line very, very close to the column. Again, all coming back to rigidity for when we're cutting tough materials. So some real key features there with this machine.
A lot of machine shops that this technology is going to be really applicable for then, job shops that, you know, are doing lots of differing materials but do maybe want to save on footprint. Yep. And make them faster, because any of the things you talk about, this machine is still very, very rapid, isn't it?
It is. So it's got exactly the same characteristics as any other Brother machine tool, and it's all about the dynamics. It's about cutting out the waste is what it's all about. So you've got 2.2 G acceleration. So by comparison to a 40 taper machine, you'd be lucky to be 0.7, 0.8. So what I'm doing is I'm cutting out the non-contact time. Will it actually cut the material any quicker? No. Will it move around a lot faster and cut out the waste? Yes, absolutely. So this is the same as any other Brother S series, R series, M series. You've got that same DNA, but it's now got the ability to cut very tough materials.
Is there any way you could quantify how much quicker that cycle time would be if you were to compare it maybe part for part? Because you must have done that on many occasions.
Yeah, sure, we've done that lots of times. So probably the best answer to that question is when I get an ISO program from a user of another manufacturer with ISO control, and I put it into the Brother control unadulterated. So all I'm using the same feed and speed data, the same program as the customer, will be 30% faster straight out of the box without changing anything. And then typically, it really depends on the application, we can see up to another 20%, so achieving 50% cycle time saving. In some extreme instances, we've seen up to 70%, and you typically see that huge extra 40% on top of, so getting me to the 70, if I've got lots of positional work. So the more positional work this machine tool has to do, whether it's going to be moving from pocket to pocket or hole to hole for drilling and tapping, the more of that we have to do, the greater the differences between the other technology, and it's down to the dynamics of the machine tool.
Is there a possibility then, using those numbers, one of these machines could replace 2 or 3 potentially, which has huge benefits?
Yeah, absolutely. So I think we've got a few customer examples that you've been to and actually videoed where you're certainly 50% faster, and in some instances up to 70% faster. So yes, I could replace 2 or 3 competitive, slower, let's say, 40 taper type machines with a high efficiency type machine. So of course then your output is going to be far higher from a smaller footprint, but then we've got to think of the power consumption that goes with it as well. So typically you're seeing between 70 to 80% saving in electrical and air consumption. So I've gone from running, let's say, 2 spindles rather than 3. I've gone from running 2 down to 1. I've actually put my output up because it's faster, and I've also saved a lot in terms of power consumption and air consumption. So it's more efficient to run, it's on a smaller footprint, as we've talked about the rigidities there in the machine tool, and it's down to that inherent speed and dynamics of the machine.
So savings all round?
So your point about job shops is very pertinent. So this machine is designed, as I've said, on a couple of occasions for tough material. And I think BBT or BT30 type machines have typically been viewed historically as drill tap type machines or lighter weight cutting with not enough power. So the F600 is aimed specifically at being able to replace 40 taper type machines in job shops where they're cutting a range of materials. It could be soft, it could be tough, it could be very hard materials. It's got the inherent characteristics to do it all, but what you've got is the thread of the speed and performance. So we're going to be a lot more efficient, a lot better power consumption, a lot better productivity output, but you've got the savings talked about.
Looking at this from both sides, there's two things that I want to interrogate a little bit further. Yeah. Firstly, is this just a change in strategy when it comes to machining to be able to machine these harder materials? And if so, also the longevity of the machine. If you are changing the way you machine things, are you likely to see an impact on its long-term performance?
Okay, so there's a number of things there. So it's a different machine in terms of capability, in terms of its structure, in terms of ball screw size, in terms of servo power, in terms of bearing diameter. So there is a fundamental change in the machine tool to give it inherent rigidity and the performance within the tougher materials. But it's also true to say, to get that very finite development of cycle time, you've got to play to the strengths of the design of the machine tool. So we have to look at strategy. So you will see performance straight out of the box on tough materials, but equally it needs refining further given the style of machine that it is. So it's kind of both elements to get the best out of the machine tool. And with regards to life, I mean, I have to say, Brother machine tools are designed to just run and run, and we've got plenty of applications where they're running 2 and 3 shifts over extended periods. And if you were to talk to our service department about wear items and top 10 lists, they would honestly struggle to come with a top 10 list of spare parts that are required for the machine, because ultimately they have been and they are a production intent machine. They're designed to run 3 shifts.